We are working on homework 2.5, equations of motion, and we're going to be doing number 5. It's got parts A, B, and C, but B is just conceptual, so we'll talk about that in class. So right here we're going to do just parts A and C. So this is homework 2.5, and this is number 5. Okay, so we have we're driving through town, and we're given our rate of speed or rate of motion, and that's 12.0 meters per second. So our initial velocity VI is 12.0 meters per second. And suddenly a ball rolls out in front of you, and you apply the brakes and begin decelerating at 3.5 meters per second. Now here's where notation, or you might say semantics, comes in. We are decelerating at that rate, or at that absolute value, so the acceleration is actually negative that. So it's negative, our acceleration is negative 3.5 meters per second squared. And the other value that we're not told, but we can assume, is that our final velocity VF is 0 meters per second. So the question in A is, how far do you travel before stopping? So that is, what is our displacement? What is our delta x? Delta x equals what we don't know. Well, we need an equation that relates initial velocity, final velocity, and acceleration and displacement. And the one that does that the best, at least of our 5, is number 5. That's final velocity squared equals initial velocity squared plus 2 times a times the displacement. Or we're going to be solving for the displacement, so first let's get rid of the VI squared by subtracting initial velocity squared from both sides. And so we have VF squared minus VI squared equals 2 times a times the displacement. And then we divide both sides by 2a to set everything equal to x. So our you know what, I'm going to start this further over to the right here. So we're going to move this up here. So x, or our displacement, is equal to VF squared minus VI squared all over 2a. So what does that equal? Our final velocity squared is 0 meters per second minus our initial velocity of 11. 12. Let's erase that right there. 12 meters per second, the quantity squared. Meters per second, the quantity squared, all over 2 times the acceleration of negative 3.5 meters per second squared. Now you can see right here, even before we get our answer, we're going to have a delta x as our answer. That is a change in displacement. Can that be negative? Well, no, it can't. It's an absolute value. Actually, it can, but it's the change in displacement is an absolute value. So our denominator, we can see, is going to be negative, but so is our numerator, because we have 0 minus something. So once again, I'm going to save space down below and put this up top. So our delta x is going to wind up equaling 20.6 meters. Actually, I don't even need to do that. I can just write it down here. I'm going to look crazy here with all the arrows. That is all equal to 20.6 meters. That's our delta x. 20.6 meters. So in part B, we're asked to predict what the speed would be at half of the distance towards stopping. And then we can talk about that in class. So that's in class. But part C, we're going to find out what it is. So at half the distance, what would our speed be as we're slowing down to a stop at half of this distance at x equals half of 20.6? what would our distance be? So our distance, or our displacement, I'm sorry, is half of this, 1/2 of that. So that's 10.3 meters. Well, still our velocity initial velocity is 12.0 meters per second. Our acceleration is negative 3.5 meters per second squared, and we need to find the final velocity. Well, once again, we have an equation that relates our displacement and our velocities and our acceleration, and it's the same one as above, but instead of solving for our displacement, which we know now, we're solving for VF, for our final velocity. And it's already written that way. Final velocity equals equals VI squared plus 2 times acceleration times the displacement. So velocity final, that is the final velocity. Remember, this is VF squared, so what we need to do is take the square root of the other side. So the final velocity is the square root of the quantity. Let's put a big bracket around that, and you might want to do this in your calculator if you put the square root sign in front of this. Square root of the quantity VI squared plus 2 times acceleration times the displacement. So the square root of that whole quantity, and that equals the square root of what is our initial velocity? 12.0 meters per second, the quantity squared, plus 2 times negative 3.5 meters per second squared times our delta x, which is 10.3 meters. Wow, that just barely fit. Okay, so square root of that whole quantity together, I should probably put another bracket around the whole thing there, equals, so our final velocity is going to wind up equaling 8.5 meters per second.